All right, this is section 8-1, the Pythagorean theorem and its converse. All right, so let's start off with looking at a vocabulary review. So we're going to first write the square of a number. So 9 squared is 81. What is the square root of 9? The square root of 9 is 3. All right, same thing with the fraction now. When we square a number, we're going to square the top, which is 1, and square the bottom, which is 16. And then when we square root, we're going to do the same thing. So square root the top, square root of 1 is 1, square root of 4 is 2. And there you go. Okay. All right, so this new vocabulary is a leg and a hypotenuse. So a leg, of course, is just a leg of a triangle. A hypotenuse is in a right triangle, the side opposite the right angle. Okay, so you just use vocabulary here. So we're going to underline the correct word to complete the sentence. The hypotenuse is always the longest side in a right triangle. All right, true, false. The hypotenuse of a right triangle can be any of the 3 sides. That is false. It has to be the side opposite the right angle. If one leg of a triangle at the right has a length of 9, okay, that is true. This leg here has a length of 9. The hypotenuse of the triangle has a length of 15. That's true. Here's the hypotenuse. Okay. So some new theorems. Theorem 8-1 and 8-2, the Pythagorean theorem and its converse. So in a triangle, if a triangle is a right triangle, then the sum of the squares of its lengths of the legs is equal to the square of the length of the hypotenuse. So here is your formula for the Pythagorean theorem. A squared plus b squared equals c squared. Now, this is something you probably have used in a previous course. Now, what's cool is we can actually determine if something is a right triangle if it satisfies. So if I do this equation and it's true, then I know it's a right triangle. All right, so let's circle the relationship that shows the correct usage. So this is the correct usage of a Pythagorean theorem. The longest side has to be the hypotenuse. All right, so underline the correct words to complete each sentence. A triangle with the side lengths 3, 4, and 5 is a right triangle because 3 squared plus 4 squared is equal to 5 squared. A triangle with lengths 4, 5, and 6 is not a right triangle because 4 squared plus 5 squared is not equal to 6 squared. All right, problem number 1. So the legs of a right triangle have lengths 10 and 24. What is the length of the hypotenuse? So let's fill in the blanks. Here is side length 10. Here is side length 24. We're going to use the Pythagorean theorem by plugging in 10 and 24. 10 squared is 100. 24 squared is 576. Add those together, you get 676. Take the square root and you get 26. So the length of the hypotenuse is 26. All right, one Pythagorean triple is 5, 12, 13. You can multiply each number by 2 and what numbers results? Okay, so when we multiply each number by 2, we get 10, 24, and 26. Okay, how do the numbers that result compare to the lengths of the sides of triangles in exercises 9 through 11? Well, the number is the same as the lengths of the sides of the triangle, and this is, so the numbers are the same. Okay. All right, so let's see if we can find, see if we can use a Pythagorean theorem to find the length of the diagonal of this computer screen. So the size of a computer screen is the length of its diagonal. If I want to buy a 19-inch monitor and has a height of 11, what should the width be? So we know that this is 19. We know that the height is 11. We don't know what the width should be. Okay, so we're going to set that up by using the Pythagorean theorem. All right, we're going to substitute in the values from the problem. All right, we're going to simplify the squares. We're going to subtract 121 from both sides. We're going to simplify. Then we're going to take the positive square root. And then we're going to use a calculator because that's not a perfect square root. And we get to the nearest tenth, the computer width should be 15.5 inches. Okay. In problem 4, let's identify what's a triangle. So a triangle has side lengths 16, 48, and 50. All right, so which equation would we use to determine if it's a right triangle? So we need to make sure that 50 is the longest side, so it needs to be plugged in for the hypotenuse in the Pythagorean theorem. So let's verify that. 16 squared plus 48 squared, does that equal 50 squared? All right, so 16 squared is 256 plus 48 squared, which is 2,304. Does that equal 50 squared, which is 2,500? All right, so adding the left-hand side, I get 2,560. That does not equal 2,500. All right, so the equation is false. So the triangle is not a right triangle. A Pythagorean triple is a set of non-zero whole numbers, a, b, and c, that satisfies the equation a squared plus b squared plus equals c squared. If I multiply each number in Pythagorean triple by the same whole number, the three numbers is also a Pythagorean triple. So it's important to kind of know Pythagorean triples because it might save us work. If we recognize Pythagorean triples, one such are 3, 4, and 5. Another one you're going to see is 5, 12, 13, and you have many more to go here. All right. Now, so Pythagorean inequality theorem. So if I know the square root of the length of the longest side of a triangle is greater than the sum of the squares, then this must be obtuse. Greater than, obtuse. If it's less than, then it's acute. So in triangle ABC, if c squared is greater than a squared plus b squared, then the triangle is obtuse. If s squared is less than r squared plus t squared, then I know this is acute. Okay. So a triangle side has lengths 16, 34, and 30. Your friend says it's not a right triangle. Let's look at the work and see what happened. So underline the length your friend used for the longest side. So my friend used 30 as the longest side. My friend should have used 34 as the longest side. All right, so write the comparison that we should be making. So 16 squared plus 30 squared, does that equal 34 squared? All right, so my friend used the wrong length for C. Okay. And that's the end of this section.